Welcome to clickmyproject.com.
Now we are going to discuss about the product smartphone based wound assessment system for patient with diabetes. Diabetic foot ulcers represents a significant health issue. Currently, clinicians and nurses mainly base their wound assessment on visual examination of wound size and healing status, while the patients themselves seldom have an opportunity to play an active role. Here, a more quantity and cost-effective examination method that enables the patients and their caregivers to take a more active role in daily wound care potentially can accelerate wound healing, save travel cost, and reduce the healthcare expenses. Patient wound image is processing under different steps such as pre-processing, RGB to gray conversion, segmentation, K-means clustering algorithm, outline and boundary detection, color segmentation, healing status, etc. Hence, the healing status is depending on the red, yellow, black color evolution model. Hence, in this process, we segment the region of interest, that is the affected region, and then feature is extracted from that region to classify whether the input is the normal or in the stage of the abnormal condition. Now we are going to discuss about the flow diagram for the process. This is the overall flow structure for the process. At first, the input image is taken from the dataset. The dataset is the folder which consists of the several input images. After getting any one input image from the dataset, the pre-processing will be carried out. In this pre-processing step, the noise removal is done by using the Gaussian filtering method. In this Gaussian filter, the noise present in the image was removed and then the enhanced images comes out from the pre-processing step. After the pre-processing, the segmentation is done by using the K-means clustering method. Here we have the output for the K-means clustering as 4 images. First one is the cluster 1, second image is cluster 2, cluster 3 and cluster 4. After getting the clustered result, the required region of interest, that is the wounded part, will be extracted from those among the 4 clusters. After that, the feature extraction is done by using the algorithms known as LBP, histogram and shift. LBP is abbreviated as a locally binary pattern, and then histogram and shift features are extracted. Those features are known as the test feature. Then after that, the classification is done by using the KNN classifier. So here we have to give the 3 things as an input for the classification, that is the test feature, train feature and then the target. The test feature represents the feature of the input image, then the train feature represents the features of the dataset images, and then the target represents the categories. After the classification, the performance is done by using the accuracy, sensitivity and specificity. By using these 3 parameters, we can justify our process is efficient. Hence, for the efficient feature extraction is done by using the LBP, histogram and shift. So LBP represents the patterns, shift represents the edge, histograms represents the color features. By combining these 3 only, we can combine the features as an test features. Hence, this is more reliable and then it will be more sensitive. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015 and change the current directory. If you want to run the code, means just right click in the main_gui.m file and select the option run. Now the graphical user interface was open. In that you can see the several push buttons in the left side for the controlling axis, and then the two axes for the display process. First of all, click the input image button. Now the dataset will be open. In that, select any one image from the dataset. After the selection of the input image from the dataset, the corresponding image is shown in the axis 1 with the title input image, and then the corresponding resized image is shown in the axis 2 with the title resized image. Now click the button pre-processing. In this pre-processing, the filtered image is shown in the axis 2 with the title filtered image. After the image noise filtering, the segmentation will be done. In this segmentation process, the image is clustered. Now the required clusters in the cluster 1. So I will give the 1 and then give enter. Now the required region of interest will be extracted from the backgrounds, and then the other backgrounds will be eliminated. After the extraction of the region of interest, the feature extraction will be done. Here the feature extraction is done by using the LBP, shift and then histogram. After extracting these three values, those values are combined together to form a test feature. Now the LBP feature is shown here. Figure 6 shows the histogram features. Figure 7 shows the shift feature. Now the shift image are also shown here. LBP image is shown in the axis 2 with the title LBP image. Now click the button classification. So here the classified result will be shown here.
Thanks for watching this video.